Good everyone, my name is Graphics. Today we are to solve this question on mechanical engineering science, which is an aspect of what mechanics, when we are told to determine the reaction at the built-in support A, right, of the cantilever beam, headed as shown in this figure. You see, headed as shown in this figure. The beam is of mass 50 kg and its center of gravity is at point G. Right, this point G here. So we are told to determine the reaction. Now we've talked about reactions earlier, Abi. Now in reactions is made from support. Your reaction is determined by the type of support. We talked about the hinge support, which is having two reactions. We talked about the roller support, which is having just one reaction. Now we're having another kind of reaction, a kind of support which is called the built-in support. Now the built-in support has three reactions, right? And let me show you as we start solving this question. Now, first thing of all do when you see a question like this is for you to draw your free body diagram. Now we said earlier that the free body diagram, the diagram that shows all the external forces that is acting on a system. Now let's see. If I should draw this bar again, I will have something like this. Now, at point A here, we have a built-in support. You can also call this a cantilever support. When you say one end of a beam is fixed, you say it's a cantilever, right? So, and it has three reactions. The first reaction will be acting upward like this, which we'll call it arrow AY, which means reaction at point A along y-axis. The second reaction will be acting along the x-axis, which will be like this, which will be arrow AX. That is reaction at point A along x-axis. Now the third reaction will now be like this, which will be the moment. I'll call it summation of what? Summation of moment about point A. Right? These are the three reactions. Why I chose moment is that if you have a built-in support, this has a tendency to bend down while this is fixed. There's about a turning effect about this fixed axis all together. So this is the moment. Moment is about the turning effect about the fixed axis here. That's why we're having the moment. And why we're having this three reaction, because of what this is fixed, is like an hinge support. Is that taken? Now we move forward. The next one we'll have is 2 kilonewton is inclined, and when it's inclined, you are having two reactions. So we have this facing up and this facing down this way. So we're having these two this way, right? So when I place it there, I'll be having something like this, right? And at this point it will be 2 sine 45. If you watch the video, I'll post the link on the front of the screen now. Click on it and you know more about the resolution of what force. So we are resoluting this force. Now this is 2 sine 45 and this is what? 2 cos 45. So if you want to understand this, click this link. Now we'll proceed. Now we have gravity. This is point B here, and this is like point A here. So the point of gravity is at this point C, and what's happening is acting straight downward this way, and gravity is what? Mass. The G is the weight, right? And the weight is what? Mass times gravity. G will bring about weight the width of the beam, and weight is given as mass times the gravity. Now we have the last but not the least. This is 1 kilonewton at this point, right? So we're going to resolve. So when you resolve it, you'll be having something like this, right? We call it resolution of force. So we're going to place it here. So in placing it there, we'll be having this. Now this will be 1 cos 30. This will be 1 sin 30. I told you if you click the link earlier, which is this link I'm posting now again, you get to understand this. Now this is point B, this is point C, and this is what? Point D. This is our free body diagram. So we've already shown all the forces that is acting on this system, right? All the external forces. So the next thing we are told to what? Calculate the reactions. So we need to look for ROAX and ROAY, and we're going to look for what? Moment about that point. So let's get it started. We're moving forward. So from this point, the first thing we have to do, I'll write it, calculating for reaction, calculating for reaction. And we know there are 3 of them, right? So let's start with the first one. We use this condition for equilibrium to calculate for the reaction. And the first condition for equilibrium is saying that what? The summation of all the horizontal components or all the forces acting along x-axis is equals to what? 0, right? Now our condition, we need to consider the forces acting towards the right to be positive and the forces acting towards the left to be negative, right? So if you look at this, we have 3 horizontal components or 3 forces acting along x-axis. ROAX is acting along x-axis, 2 cos 45 is acting along x-axis, 1 cos 30 is acting along x-axis, and they are all facing towards the right, so they are all positive. So I'm going to have the ROAX, right, plus 2 cos 45 plus 1 cos 30 equals to what? 0, right? Now when you do that, if you press 2 cos 45, we'll be having ROAX plus, so we'll be having 1.414 plus 1 cos 30 will be 0.866. This will give us equals to what? 0. Now when you add 1.414, you're going to be having my ROAX plus 2.28 equals to what? 0. Now we move forward. If this comes to the other side, the ROAX will be equals to minus 2.28 kilonewton. This is for my ROAX. Now move to the next one. Next condition for equilibrium that says that the summation of Fy, that is the summation of all vertical components or the summation of all the forces acting along y-axis, is equals to what? 0. Now we want to consider the upward force to be positive and the downward force to be negative. Right? So we're moving. So from what we have here, we have 4 vertical forces, which is arrow AY, 2 sine 45, the weight, then 1 sine 30, right? And we have 2 upward force with 2 downward force. So let's see how that goes. The first one is arrow AY facing up, which is positive. So I'll write my arrow AY. So this is arrow AY. Then plus the next one is what? 2 sine 45, which is facing upward. You can see that? Facing up, 2 sine 45, that is positive. So I'm going to be having 2 sine 45. 2 sine 45, right? Then plus the next one we have is facing down, and that will be minus W, right? Look at it, minus W is facing down, so this is it, facing down, W, then minus 1 sine 30, so we have minus 1 sine 30 equals to what? 0. Now when we do that, we know very well, I can write it by saying the arrow AY plus 2 sine 45 will give us 2 sine 45 is giving us 1.414 minus the weight is giving us the mass times gravity minus 0.5 equals to what? 0, because 1 sine 30 is 0.5. Now we move forward to the next one here. We have arrow AY plus 1.414 minus the mass from our question is giving us 50 kilogram. Let me post the question again. Look at the top right corner of the screen. The mass is giving us what? 50 kilogram. So we see the 50 multiplied by the gravity is giving us 9.81 is a constant meter per second square. Now if you notice something, the mass is in kilogram, the gravity is in meter per second square. So to make them conform, I'm going to divide both of them by what? 1000. That is, I'm dividing 9.81 over 1000. Now minus 0.5 equals to what? 0. So I'm dividing 9.81 by 1000 so that it can conform with what? The kilogram. So it will be kilometer per second square. Right? Now we move forward. From here we have the arrow AY plus 1.414 minus, if you multiply 50 multiplied by 9.81 divided by 1000, we're having 0.4905 minus 0.5 equals to what? 0. Right? So if you do all your estimation here, we'll be having RAY plus 0.424. That means 1.414 minus 0.4905 minus 0.5 will give us plus 0.424 equals to what? Equals to 0. Now we move from here. The RAY will now give us minus 0.424 kilonewton. So that is the reaction RAY. Now, since we have RAY and RAX, these are two reactions, we need to get the resultant reaction, right? Because we have two resolved reactions, so we need the resultant reaction. So what we'll do is calculating for the resultant reaction, calculating for resultant of RAY and RAX, we are going to use this formula that says that, recall, my resultant R will give me the square root of summation of fx all square plus summation of fy all square, right? So all the forces along x-axis, we say that the arrow now will now give us, we have all the forces along x-axis is given as what? Arrow ax. Then we have what? Square. Plus the force along y-axis is given as what? Arrow ay. We also have what? We also have what? Square. Right? Because f of x, the force along x-axis is RAX and this is RAY. Now if I impute my formula, we have the square root of RAX is giving us minus 2.28 all square plus RAY is giving us minus 0.424 minus 0.424 all square, right? So from here we move forward, and this is going to give us the square root of, if you press 2.28 square, 2.28 all square, we'll be having 5.198. we have 5.198. The negative will equate because of the power is even, plus 0.424 square. So we'll be having 0.1798. 0.1798. That's what we have. Is that begin? Now if you add both of them, we have 5.198 plus 0.1798. That's going to give us 5.377, right? So we see this will give us the square root of 5.378. Now if I press the square root of that value, my resultant R will be giving us what? 2.32 kilonewton. That is the resultant of the reactions, right? Now the last reaction we have to calculate here is this. is the moment, right? We have to calculate for what? The moment. We've done for ROA x, ROA y. Now we want to look for the moment. Now in calculating for the moment, we have to follow the condition for moment, which is summation of moment. Let's do that. So we have in the summation of moment about point A, right, is equals to what? 0, and we want to consider clockwise moment, which is what? Positive, and anti-clockwise moment, which is what? Negative, right? So I will use this to explain to you. Let's assume this is my clock. 12, 6, 3, and 9. So I'll explain this to you what it means to be clockwise and what it means to be what? Anti-clockwise. Now we know that recall moment is equal to what? Force times what? Perpendicular what? Distance, right? And we have more than one moment because we have different force. So for you to use moment, the force have to be perpendicular to the distance. So let's see. If I come here, the first one, this is parallel force is 180, it is not 90 degree, but this one standing is what? Is 90 degree. You can see to the distance, and it will be going towards point what? Towards point A, because that is where we're taking moment. So the force times the distance. So what is the distance? Distance from B to A, right? B to A is what? 0.2. You can see that it is 0.2. That means distance from here to here is 0.2. So I'm going to put it this way, and it's going this direction towards point A. Now if I come here, anything going like this, what do you notice? It's going against the direction of the clock, and that is what we call anti-clockwise. And we say anti-clockwise moment is what? Negative. So I'll be having minus 2 sine 45 multiplied by 0.2. That is the first moment here. Now the next thing we'll do is the next one, which is the mass times gravity. If you notice it is also forming 90 degree here. So, and it will be going towards this direction because of the arrow is facing down. So going towards direction and going towards point what? Point A, right? So when something is going like this, let's check here. If something is going like this, that is the direction of the clock, so that is clockwise, so it's positive. So it's going to be plus brackets the mass times gravity multiplied by the distance from here to here. The distance from C to A, let's see, distance from C to A, this is C to A is 0.2 plus 0.2, that is 0.4. So times 0.4. So we have the 0.4. Now plus the next one we'll do will be the last but not the least, which is, if you look at this force says horizontal, so it's 180, is not 90, but this here is what? 90, and the force will be going towards direction since the arrow is facing down, so it will be going towards direction, right? And when something is going towards direction, it's positive, clockwise. So we have the 1 sine 30 multiplied by distance from D to A. The distance from D to A, you can see that from D to A is 0.2 plus 0.2 plus 0.2, that is what? 0.6. So I'll be having the 0.6 times 0.6. So that's what we have in our bracket here. So we can search forward and see how we can continue with this question. So let's see how that goes. We know that 2 sine 45 is giving us 1.414, right? So times 0.2, let me just write it here, 1.414 times 0.2 to the negative here, right? And the next guy we have here, plus the mass times gravity. We know our mg is giving us what? We said mass is 50 multiplied by the gravity 9.81 divided by what? 1000. I explained it to you earlier in the video. Then everything here multiplied by what? 0.4. Is that taken? Everything here multiplied by what? 0.4 plus 1 sine 30 is 0.5 times what? 0.6. So we'll move forward. Now we're going to the next guy. 1.414 times 0.2, that will give us 0.283. So this will give us negative 0.283, right? Plus everything here will give us 0.4905 times 0.4, right? So plus 0.5 times 0.6 will give us 0.5, that will give us 0.3, right? So we're moving forward. From here we'll now say the minus 0.283 plus, if I multiply 0.4905 times 0.4, that will give us 0.1962, 0.196, right? Plus 0.3. Now when you add everything all together, that is minus 0.283 plus 0.196 plus 0.3, that will give us 0.21, right? So we're having 0.213 or 0.215. So we have 0.213. Is that taken? So from here equals to what? Everything we're doing here is equated to what? 0. Equated to what? 0. Now since the moment is equal to 0 and this is equal to 0, so we can easily say that our moment, or better still, we can say that from here we can say the summation of moment, since about that point A is equals to this, right? So from here we say my moment will be giving us, if it's coming to the other side of the equal sign, that will be giving us what? Minus 0.213. How good? So it is minus 0.213 kilonewton. Is that again? Now that is not the end. You see, in our earlier solution here, we calculated for the resultant force and the what? The reaction, right? Now this is the reaction. I told you whenever you calculate for resultant force, you have to calculate for the angle at which the resultant force is inclined. So in doing that, we know that from here, let me just do it here, that our tan theta is equals to what? The summation of f of y over what? The summation of what? F of x, right? So we know what this value is. At the end, at the long run, this is something as saying the f of y here that we have is giving us 0.424. F of x giving us what? 0.28. This is like negative, they're equating out. So by the time you do what you want to do, you are going to be having this. So we have the tan of that to be, let's see, 1.514, right? So from here we can just see that the tan theta is giving us 1.514. So to look for theta here will be given tan inverse 1.514. So theta will give us 10.53 degrees. So that's our angle theta. So whenever I calculate for resultant force, we need to calculate for the angle at which is inclined. So if you found this video helpful, please don't forget to click on the subscribe button, and don't forget to like, also share with those you feel like they are in need.